let's take a look at a parabola opening to the right. And the very first thing that I want to do in order to graph the equation, I would rather have the y alone. And so I'm going to recommend that you always do that when you are asked to graph something, to get the y alone. And unless you already know what it looks like, and most of the time at this stage we don't know what these look like. So let's go ahead and take the square root of both sides to get the y by itself. Now you notice that I didn't see any square roots when I looked at the problem originally, so I have put the square root on both sides. When I apply the square root, I must use the plus or minus. I must use the plus or minus, okay? So there's me getting y alone. When I get y alone like that, let's go ahead and get our table of values set up. I'm going to go ahead and take a look at putting in some things, and immediately you're going, Ms. Savell, that you're not going to be able to put in a -2. So it's true. I'm not going to be able to put in negatives into the radical, right, where the x is, because I can't. I want real values, and those would be imaginary. So we're going to just start with 0. But my typical pattern is to put in a few negatives, a 0, and a few positives if I can. So here we go. We're going to put a 0 in. And we notice that that's plus or minus, and so we get square root of 0 is 0. Well, there's no such thing as a plus or minus 0, so we just get 0. Okay? I put in a 1, and that's plus or minus 1, so what square root of 1 is 1. So what I get on this situation is I get a plus 1 and a minus 1. Well, that right there explains something about this relation. It is not a function. Do you notice the open beak? If you've been watching the videos in order, you know that when we see an open beak in a relation, then when we map it from x to y, then it's not a function. But let's take a look at, so we're going to say immediately, not a function. Not a function. So it's not a function, but we are going to go ahead and get some more values so that we can graph the thing. Alright, if I put in a 2, that's going to be a nasty decimal, so I'm going to probably just skip over the 2, and I'm going to manipulate, I'm going to cause my numbers to be numbers that would work easily in this equation. So I'm going to put in a 4. So put in a 4 plus or minus. That's going to give me both a 2 and a -2. Alright, so let's go ahead and get some of these values mapped. Plotted, excuse me. 0, 0. I have over 1, up 1, but I also have over 1, down 1. I have over 4, up 2, but I also have over 4, down 2. Now, if I went ahead and put a 9 in there, we know that we would have a 3 and a -3 coming out of that, right? And so, again, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm estimating that, and that's about like that, and that's about like that. So here's what we have. We have a parabola opening sideways like that. Well, that's obviously not passing the vertical line test, so it's not a function. We knew that when we started seeing the open beak. Let's take a look at what the domain is. All right. So the domain. What was the input? Let's just pretend like we don't see the picture. I want to transition us from having to have a picture to being able to look at a table. If I look at the domain, negative values were not allowed. 0 was allowed, and positives. In other words, I could go from 0 to infinity. In looking at my table, I can see clearly that those are the values that are okay for x. Let's take a look at the range by looking at the right side of my table. Did I have negative and positive numbers? Yes. Did I have 0? Indeed I did. So I'm going to go, hey, that's just the whole number line. Negative infinity to infinity along the y number line that way. Okay, well, if I look at the visual of this, the x does look like it would be 0 to infinity, as all of these little particles, snap to the strong magnet. Same thing with the y, the range. These would go up, these would go down like this, and we would have negative infinity to infinity. All right, so I hope that helped, and thanks for watching.